Today we're going to be going over like normal distributions. And of course, for any newcomers, since we've got a couple, you can just head over to resources and it's this one right here, normal distribution. We have the whole idea of normal distributions and normal distribution curves, which is a scarier topic, some would say, for methods, especially with some overlap into spec for those that do spec. And these are everything you see here, these 5 ideas, is basically everything you need to know to be able to get through or understand everything you need to know for spec. There's this key formula for z-score here is an essential for like finding unknowns when it comes to standard deviation or whether it's the mean and sometimes the actual x value that corresponds to that z-score. And then, of course, by now, I think most of you guys should have a clear understanding of what the mean and the standard deviation squared is in this notation. And just remembering to square root the standard deviation squared to actually get the standard deviation, which is probably the more used value when it comes to these questions. And sometimes they're kind enough to remind you by actually putting the squared there. And of course, for simple familiar questions, you should have this also memorized, the whole 68%, 95, and 99.7% rules for standard deviation. We'll see these rules as we go through the questions. So let's actually go through question 1. We'll start with question A. And this is a pretty simple familiar question. I mean, it's just calculator crunching. They've asked to give us the probability of each of these events happening to the nearest 4 decimal places, which is very common for these normal distribution questions. So the first thing, as for any normal distribution question, is you end up drawing this curve, which looks very perfect, and the peak will be right there. And that will be your mean value, which in this question is going to be denoted by this first number here, which is going to be 250, 250, 250. And our standard deviation is going to be square root of 4 squared, which is, of course, 4. So one standard deviation is going to be 4. And we are asked to determine the probability that V, so that's the event V, which represents a volume of like coffee within this coffee machine's dispenser, probability that V is less than 245. So we can draw out a line for 245, which is around here. Actually, can we undo that? Actually, it'll be a bit further than 1 standard deviation since 4 is 1 standard deviation. So it'll be somewhere like here. So we'll do 245 there. And we want to find the probability of getting this whole area here. Okay, so this is the part where we need a calculator. As we don't have one, if you have the Casio CG, whatever the white calculator is, the standard calculator that's recommended, I'm pretty sure, what you would do is you would go to your menu, click 2 or wherever your statistics is, and then press distribution, normal distribution, NCD, I think. NCD is what it's called. And then for your lower value, you would type in 0, and your upper value, you would type in 245. And for the mean and standard deviation, so we have a mean of 250 and a standard deviation of 4. You type all these values in and you should get your probability. Would you type negative inf or 0? You would just type 0 because you can't have negative infinite volume. You got an answer of 0.1056 for this question. I was standard deviation 4, not 4 squared. Okay, the second digit here in this notation, that's actually your variance. And 4 squared is the variance. So variance is 16. And your actual standard deviation is square root of variance. That's the formula for standard deviation, square root of variance, right? And based on variance being 16 for this question, we just get a standard deviation of 4. Does that answer your question? Let's clear all of that. And for the second part of the question, which is part B, it is essentially the exact same thing where you would sub in values again, with lower being 258 in this case, as we want the area after that is greater than 258. 58. And what you will notice is it's actually 2 standard deviations to the right of the mean, which would mean that the answer should be around 0.025, based on our knowledge that within 2 standard deviations on left and right covers a 0.95 confidence interval. But we know based on this rule that if it's 2 standard deviations away, that will cover 95%, approximately 95%. So based on that, we should expect an answer around 0.025. And that is verified by M's result of 0.023. The timeline T of a rechargeable battery is approximated normally, that's what that N stands for, with a mean of 18, and we have a variance of 2.5 squared, so a standard deviation of 2.5 months. The shaded region below shows P 15 months to 20 months, okay? Using the distribution above, determine the probability that it's between 15 to 20 correct four decimal places, all right? This is another just calculator job. This time they've saved me from having to draw a normal distribution, which is great. So we can go to a lower value of 15, a upper value of 20, as we're going to be finding the area from 15 to 20. Then, of course, subbing in the mean of 18. This part's the easy part, and the standard deviation, which we just read from this time is going to be 2.5, because once again, we square root 2.5 squared, 0.6731. One way we could verify that is it's very close to one standard deviation on both sides. Actually, it extends a little bit over on one side and retracts a little bit over on the other, and 0.67 is near that one standard deviation mark. A battery is marked premium if it lasts more than 22 months. Determine the probability that a randomly chosen battery is premium. All right. So this time they've kind of added extra steps. They haven't just told us what probability to look for. They've made it a worded question to make it a more complex question. But this is just a SF question in disguise. That's what CF questions tend to feel like. So it's marked as premium, and you're going to find out the probability of it being premium. So it has to last more than 22 months, which is the same as the lower being 22, upper being infinity. So you just sub in like a really large number. So you can just do 10. So 1 times 10 to the power of 9 or something like that. That'll be large enough to give you 4 decimal places. And then, of course, the mean and the standard deviation. And that should give you a decimal value. And if you just convert that to a percentage, that should give you your percentage probability. And it should be a relatively small number by the looks of things. Okay, and has given us that answer, and it seems about right. So the chance of a premium battery is 5.48%. We could verify this by looking at where 22 months is. It's always great to verify stuff in your head. And we'll realize that if we look at standard deviation of 2.5, 2 standard deviations would land us at 18 plus 5, which would, of course, be 23. And we want to know when it's greater than 22. So this would fall just under that 2 standard deviation point, which would mean that it would be greater than a probability of 2.5 based on the 2 standard deviation rule that we discussed in the last question. So 5% seems reasonable enough. So we'll move on, assuming that we're correct. This time they want us to actually draw, so you guys can go ahead and do that. We know the mass of a bag of flour is going to be 105, and we did have this drawn out previously. Over here, so right, we have 105 as your mean, and we have 8 squared as our variance, so 8 is going to be our standard deviations. I'll just have a nice little 8 there. The heaviest 5% of bags are set aside for rechecking. Determine the minimum mass of which a bag is rechecked. All right, so what we want to do is we want to find at which area. We know that if we have this area on this right-hand side here, that's going to be 5%. We just want to find what X value corresponds to that 5%. Now, for a question like this, we need to find the Z score that actually corresponds to having a 5% at the end frame here. And now to find that Z score, there is a function on the calculator that helps you find that bottom area. It is in the same statistics area. It might be in like NPD or instead of NCD, I don't know, somewhere in those settings. You can set it so you have 5% of the area from the right-hand side, and it should give you a Z-score value. So we have a Z-score of 1.64. Let's just verify your answer that you got through inverse N. Let's do that by just going Z equals what? 1.64. So we got that from the calculator. So over here, we'll put down like GC, graphics calculator. I'm pretty sure there's a better word for it. And we know that the Z-score is equal to X minus mean divided by the standard deviation. So we should have 1.64 is equal to the X value of this point, which is what we're trying to solve, minus the mean, which is 1.005, and this whole thing divided by the standard deviation of 8. And if you crunch this into the calculator, you should get the exact same answer as the inverse n solution, which would give you 1018.16. So yeah, that's how you'd go about it. You'd get a closer answer to the correct answer if you add more decimal points to the z-score. That's the only place where we have rounding error. Why can't you just do inverse n? That is another way of doing it, but I tend to like doing it the longer way because it's more working out. And I don't know, sometimes it feels like when you just sub it into a calculator, it's a bit of a cheat, and instead using the z-score rule can just like ensure that you're getting the marks on the way. But yeah, you could just use inverse n and sub in the values for like the mean and the standard deviation and just sub in like what thing you want. So I guess, I mean, for an SF question, yeah, 100% go for that because I mean, all they really want is you to sub in some numbers. It is a 2-mark question, so I think you could get away with that. So for part B, you would essentially do the same thing with inverse n. Okay, next question, we're moving on to juice cartons. That's interesting. So for these type of questions where there's an unknown, this is when that z-score formula that we talked about comes in handy. We have a z equals x minus the mean divided by the standard deviation. And here we already know the mean value of 2000. So that's going to be great, easy to sub in. And we also know that 2.5% of juice cartons contain more than 2050 milliliters. Now, it's known that 2.5%, so 2.5% in a in a tech-free world, that would mean that in this curve, above this and below this, that's going to be 2.5. And then the middle area would be 95. And the bottom area, the top area would be 2.5 again. And just off memory, I know that the z-score to produce these numbers would be 1.96 or 2 is what they would say in tech-free, but I'm pretty sure in tech-active it would be 1.96. So we have a z-score of 1.96, and we also have the x value at this particular point, which is 2050. We have the mean of 2000, and we want to find the standard deviation. So if you sub this into a calculator, rearrange a little bit, multiply by that, and then divide by that, you should get 50 divided by 1.96, and you get 2.55, which is the show that answer. So you get equals 225. And yep, that's exactly how you'd go about to do that question for part A, and hence determine the probability that the volume will be less than 1960. All right. So when it says hence determine, it's telling you to use part A in your solution. So from part A, we already know now that we know what the standard deviation is. Finding part B is pretty easy. It's an SF question now, where we really just sub in. So to find part B, we do the same thing that we do as always. So we have a lower of 0, upper of 1960, and we sub in the exact same values that we have. So we actually calculated that the standard deviation is 25.5. So we're going to use that value there. And yes, there are some more decimal places, but since it says to show that it's approximately 25.5, I'm sure it's fine to just leave it at that one decimal place standpoint. And then we'll have the mean of 2000. Sub all those numbers in, and you get an answer of 0.584. All right, then now let's move on to part C. So we want to find the area of it containing at least 1950. So we have 1950 here. Let's find the probability that the area is greater than 1950, which is around 2 standard deviations away from the mean of 2000. We know it's probably going to be around probably like 97% chance that it's more than 1950. So if someone would be kind enough to do a lower of 1950, an upper of 10 to the power of 9, and a standard deviation of 25.5, and a mean of 2000. So we get our answer of probability of 97.5%. So means there is a 97.5% chance that on a given random juice bottle, there will be more than, or at least 1950 milliliters. I think claim is reasonable because that's a pretty high probability of there being 1950 milliliters. However, there is obviously a chance that is less than it. So you could argue it both ways. A lot of this normal distribution work is really just calculator crunching, just wrapping your head around all the three different things that you can do with your calculator. One of them just being the normal distribution probability, which we've been doing quite a lot of recently, with the lower value, the upper value, the standard deviation, and the mean value. Second one being the inverse n, which is kind of the opposite, where you know the like central area, and then you know how much of that area, if it's central, if it's to the right, if it's to the left, and they'll give you the exact values at those points. And then finally, you can also use it to find the z-score, which is a whole other method as well. And once you can wrap your head around those three things that you do on the calculator, that should be enough to get you essentially full marks for all these normal distribution questions. So before we get into C questions, I'll let you guys have a go at this question. I'm assuming you're going to have to use the z-score formula, which I'll just write down for you guys in case you've forgotten. Z equals the x value at a given point minus the mean, all divided by the standard deviation. Go ahead and try this. So we know that this student got a 70 in math. So that's our x value of this curve, in case anyone wants to see what that looks like. So that's going to be your maths curve, where 15 is that standard deviation. And then let's do the same for chemistry, where we have a higher mean score of 51 with an even bigger standard deviation of 20. Okay, those are your two curves. And this student got a 70 in math, and they got a 76 in chemistry. So we know that the student got a 70 in math and 76 in chemistry. So both of these results are more than one standard deviation away, but that's not enough to tell us which one got what score. And first of all, we need to find that z-score for mathematics. So if we sub in the values from part A into that z-score formula, we know that they got an x value of 70 for maths in particular. So we got 70 minus the mean of 45, and that entire thing divided by 15, you will of course get 5 on 3. And that's going to be your answer to the first question. Part B is going to be finding the z-score for chemistry as well. So it's going to be the exact same thing. So it's going to be 76 minus 51, which will also give you 25, and then you'll divide that by the standard deviation, which is going to be 20, and that'll give you 5 on 4. Z-score 5 on 4. Now they've also asked us to find the percentile rank of each result. Now that's when stuff might get a little bit trickier, because you want to see how do you convert a z-score to a percentile. So you know that same place that we were doing the lower and the upper and the standard deviation and the mean values? What I did in high school to get these percentiles is for standard deviation, I would set it as 1. For mean, I would set it as 0. And for lower and upper, I would do this based on the z-score. So for, let's say, the percentile for math, let's find the percentile for math first. We have a z-score of 5 on 3. So your upper is going to be the z-score of 5 on 3. And then your lower is going to be negative infinity, or just negative 10 to the 9. Because that way, what it'll cover is, on a normal distribution like this, from here 0 to here 5 on 3, we'll have this entire area shaded, and then you'll actually figure out what percentile he'll be. So if you just put those values in that I have here into a calculator, it'll give you a probability, and that probability will actually be the percentile that they're better than, or they've got a higher score than. And that's how that percentile calculation works. And if you do this exact same thing, but instead of the upper being 5.3, I mean 5 over 3, you do 5 over 4, then you get the percentile for chemistry. Based on putting these numbers into the calculator, you should have gotten 0.9522, which is going to be the 95th.22nd percentile. The chemistry percentile is going to be less than this because the z-score is less. So we do know, based on this, that we can rank them, and they clearly did better in mathematics than chemistry because the z-score is further away from the mean. So a higher z-score would mean they're further away from the mean, which means in this case, they're doing better, since it's of course a positive z-score. If it's a negative z-score, that means they'll be doing worse. Let's move on then to the next question, which is a CU type question, and this will probably be the last question that we go through. You guys can feel free to go through this long question in your own time. You guys can have a moment. This time I'm taking a look at Vanessa's scores in English and history, both subjects that scale terribly, so I'm not sure why she's really cares. Both sets of results are normally distributed, and the following is known. English, the probability of x being greater than 45 is 0.89, and the probability of x being less than 70 is 0.8. So let's draw out the English curve. So we know that the probability that x is greater than 45, so here's 45, is 0.89, and we know the probability of it being less than 70 is 0.8. So we know that this whole area is 0.8 and the opposite area is 0.89. Let's try to figure out how we can actually find the mean and the standard deviation values, because what they've given us is they've given us 2 points. They've given us two x values actually, and they've also given us two percentiles, or the amount of area that they cover. So let's try find the z-score based off these values. So what we're doing here is we're working backwards, because we don't have the mean or standard deviation, but what we do know is that at this x value of 45, when x is greater than 45, so for everything past 45, we know that this whole area is going to be 0.89. If you set the tail to the right-hand side, and then the area would be 0.89, you can essentially find out the z-score. What we can convert this into, now that we know the z-scores, is we can just get rid of this. And we just know that at this x value, we get a z-score of negative 1.23. And at this other x value, we get a z-score of 2.84. That's all the information we essentially need to actually find some type of mean and standard deviation for the English result. That is a good question. So after you get the z-score to a unique curve, that z-score is like standardized. So it applies to that particular curve, right? That z-score applies to that particular curve and it's for that particular value. So that person scored a 70, right, for mathematics, and they got a z-score value that was pretty good. Now, if someone scored a 70 in chemistry, that z-score value could be completely different because there's a different mean and a different standard deviation. But the z-score lets you compare these two different curves on a percentile-based system. So yeah, so the z-score is how many standard deviations from the mean are you away? That's the definition of z-score. You can compare how far away from the mean and standard deviations you are with other curves because of this. Okay, so let's move back onto this question. We know the z-score values that we're given here. So we're gonna have to use simultaneous equations. Like we have a z-score of 2, 3, and that's going to be for the corresponding x value of 45. And we have minus the mean, and that whole thing divided by standard deviation, and then that's going to be our first formula. And our second formula is going to be 0.84 as our z-score. And the mean is going to be the same for these two equations. So it's the same variable that we're using here because it's the same function. And that's going to be our function 2. And now is when we sub in these two equations through simultaneous equations. You can rearrange the standard deviation onto one side and then divide one by the other. That's one way of solving it. Or you can just sub one whole equation to the other equation. Sometimes you will get a mathematical error, and if you do get that mathematical error, just try rearranging it a different way to use simultaneous equations. That means the mean is 59.81, and then when you sub this back into either one of these equations, you'll get a standard deviation of 12.13. And that is going to be your answer to part A. And you can do this exact same thing for part B. And then part C is just a justified type question, so it shouldn't be too hard. I think there is a small twist to part B, maybe. It says look carefully at the two history facts. But yeah, that is essentially all for today.